these objects were within the selection, whereas this object passed through the select command. So by this you can select which object you want. So this is the default boxing command of selection. So the next method is the fencing option. So you can click on it again, and two ways of selecting the subcommands are either you can click on the option that you have in the option menu here, or alternatively you can click on the down mouse arrow to select the next command that you want. So now let us select the fencing command. So fence means that through whichever objects the line passes through, that object will be selected. See, when we move this line across, you can see the objects getting selected at once. Suppose we want to select this object and then all the objects passing through the second line. So I'm terminating it by clicking in enter. So now you can see the objects that were passing through this fence had been selected. So if suppose there's a complex object with different sizes, or consider a polyline, an arc, and so on, and you have to select multitude of components but they have different boundaries, then you can select the fence commands to draw a polyfigure through which all the selected objects can be highlighted and worked upon. So that was the fence command. So next look into the next command, a window polygon. So in window polygon, what it means is it's typically same as the box command, except that box is a rectangle, whereas here you end up with a polygon. So whatever you are seeing in the initial polygon, that is W polygon, means it is within the selected polygon. So suppose if we are selecting a polygon of this area, then whatever objects that are enclosed within this polygon have been selected. So this is the W polygon command. Alternatively, you have the next command, that is the C polygon. So in C polygon, you can select all the objects that are enclosing within it. First point, the second point, third, and fourth. You can see the color that is being varying as blue and green. So you end up with selecting all the objects because it passes through whichever objects that are touching the boundaries of the polygon will get selected. So typically you have to be sure of what selection that you want to intend to select, whether it's inside the selection area or passing through the selection area as a whole. So based on that, you get designated blue space or a green space, and by default you have a box command, that is a rectangular command. And if you want to go for multitude selection, then you can go for a polygon based one. And alternatively, you also have a fence command to select all the objects that passes through the line that you draw. So those lines need not require to be closed, whereas the box or the polygon needs to be enclosed, whereas the fence command can be an open-ended one. So this is one type of selection tool that is available. So next, we also have a select command. So we can invoke it by clicking on select. So here you select the objects individually. So let me just close the command line because in my PC it takes rendering time. So we click on select command and select the objects that we want to select. Suppose by mistake we have selected this circle and we have to do away with the selection, then we can type on R for remove to remove the object. And if you want to add some more objects to the selection, then you can click on A for add and click on the next object. So this type of selection is based upon the object or the feature, wherein you select the feature one by one. So where this selection command is of predominant use is that if you want to do an editing option onto the given object, so then you use the select command. So in certain commands, suppose if you click on the move command, you are expected to select the objects here. So it means that this select command succeeds the move command. But suppose if we have selected the object well in before, okay, and then inside the select menu itself, if you click on the move object, pardon me, so you select it, select the objects of interest, close the command, you get the object selected, and then click on move command. Then those objects are pre-selected and it goes to the next step of the move command, that is it expects the endpoint or select the base point for movement. So this is one way of utilizing the select option to pre-select the objects that are intended to be edited and then go to the respective command. So these are small tool tips for you for quickly operating with your editing menu. So what we have seen was the different views, zooming command, and next we also looked into the steering wheels, and also we had solid and donut option that we have seen, and now different selection commands. So based on that, this concludes the basic navigational techniques that are available in AutoCAD. So next we'll look into some sample exercise files. So now let's practice the friction plate drawing that is shown here. So we'll try to use all the tool commands that we have seen so far. So today's session we have seen different navigation techniques, selection techniques, and zoom commands and all. So let us try and use those. And parallelly, last week what we had seen was using different editing commands such as move, copy, array, break, mirror commands. And previous to that, we were seeing circle commands, arc, rectangular commands, and line commands. So we'll use these fundamental base commands to draw this diagram. So here you have to be very particular about the dimensions, key dimensions. So before proceeding to draw any new drawing, always make sure you are very clear with what the drawing entails or called for. So first, the application you have to be very clear. So this is a friction plate that's going to be used in an automotive comp engine or a gearbox. So here you could see you have on the center a slotted hole or a spline hole wherein this friction plate will get assembled onto the drive shaft using a sliding mechanism. So this slot will ensure that it can travel along the shaft, but it will get constrained by these slots, and hence when there's a rotational motion of the shaft, the plate also revolves with it. So this is one way of constraining the motion of a unit. So this is how your friction plate works. So typically this is in your clutch housing. So when you declutch, the friction plate material is pushed against the flywheel, so it breaks the mechanical force or the rotational torque that is available at the engine. So that typically means it slides away from the clutch. So when you re-engage the clutch, it slides back to its position and the friction material will hold on to the clutch, and then you get the power. So this is the functional unit of the current drawing. So you have to be understanding the each and every functional aspect of it to clearly understand what each component or what each object entails. So next, on to the boundary, again you can see some slots. So basically over and above this friction plate is where you will be getting the friction material, say it's asbestos or ceramic material that's going to be embedded onto it. So in order to embed them, you have 8 holes that are listed. So those are the riveting holes through which the friction material is clamped onto the friction plate. So next you also see 4 slots on the outer side. So that is where you will be getting the torsional springs enclosed onto those sections. So these are the different aspects of your drawing. So next let's quickly look into the dimensions that are included. So the inner circle, that is the inner slot wherein your shaft sits in, has a diameter of 50 mm. Onto that you have 4 slotted holes. So those are of rectangular cross section with width of 12 mm and height of 6 mm, and with respect to the center line it is offsetted by a 45-degree angle, and you have 4 slots in that manner. Next, if you could see the outer area where you are riveting your portion, where the holes are located. So the holes are located at the pitch circle diameter of 122 mm, and the overall material external dimension is 154 mm. And again, the spring area where the spring is going to be seated, that clearance width is of 30 degrees with respect to the center, and at either part of the center line it is distributed, so it is equally slotted with 15 degrees and 15 degrees there. And also the rivet holes are also located from the center point of the axis in 30 degrees, and each and every subsequent rivet holes is spaced 30 degrees with each other. So this is the typical dimensions inference from this drawing. So always please have a note of the units again. So all the units here are mm, and then again what is the dimension space you are working on, what is the maximum dimension, and check whether your limits are all okay, and then look for key dimensions that will help you to construct the drawing, and finally the application where it is going to be used. So now we'll start the drawing. So in the new drawing we'll start off with ensuring the units are in millimeters, and next the limits have been turned on, and also the lower and upper limits for A3 or the A2 size or whatever you are working on has been ensured. So we are using the same limits session. So to ensure that we stay within the extents, we first initially click on the zoom extents option so that the maximum dimension of the limits is captured. So next, now start off with the initial inner circle, that is the inner shaft area. So we select the circle command, center as here, and select the diameter of 50 mm. So once it's done here, so let us go back to this object, and now next objective is to draw a slot of, that is a rectangle. So let us initially position it outside here. So the dimension is going to be 12 mm in width and 6 mm in height. So now let's move this rectangle over to the circle that we have drawn here. So this is going to be the object. Clicking on enter, and then the base point is going to be this, and next we are going to position it along the point here. So next is we have to move this slot inner, because as you could see on the dimension, it's not on the outer but on contact with this circle. So in order to effect that, we again use the move command. Select this object, select this, and then click on to the object. But as you could see, the snapping is snapping onto the perpendicular point, but then it always shows the nearest point. Our objective is it has to be positioned perpendicularly down. So let us use the polar snapping on by using ortho snapping, that is F8. So once you have done that, it will ensure that the snap stays to here, and you can see the nearest point is taken as here. But there might be a little bit confusion stating that, see, now we have snapped onto the nearest point, but when you zoom it closer, there might be seen as a difference. but you can verify it by regenerating the command. So now you can see it perfectly sits onto this. So now let us come back to the overall view. So now we have positioned this rectangular slot onto this inner circle diameter of the friction plate. So now going back to the drawing, we can see that this plate is not on the 90-degree axis but rather 45 degrees inclined to the center line. So we'll use the rotate command to move this object onto this position. So we are going to rotate it with reference to the center of this circle at an angle of 45 degrees. So this is done here. Next, what we are going to do is we are going to use the polar array option to replicate the other instances of this rectangular slot. So before that, we can also see that this component needs to be eliminated, right? So towards that, we use the break command that we have seen in the previous week. So the first off is we have to remove these two sections. So first let us try and remove this bottom part of the rectangle. So here the first selection point is taken by default, so let us click on F to override the first selection point. So we are selecting this point and this point. So now we have removed the bottommost part of this rectangle. So now let us use the array polar command to replicate this object. So the center part is going to be on the circle and the number of items is going to be 4. Right? So we are done with this. So next is to break off this segment. We have to remove this arc. So one way is you can use the break command again to select the object and go about in anti-clockwise direction to do it, or alternatively what you can do is you can also remove the circle as in whole and then try and draw an arc between them with the same dimension. But when you're using the break command, again you are effectively breaking the polyline, then ensuring that it is taken into separate objects. So this is now a separate entity, whereas this is a separate entity. So you can go about in those. So one way is the break command. The other way, let's see how we can use the arc command. So we are deleting this object and then using an arc command and pressing on down arrow, we can select the center of this. And then first part. So let us take away the ortho command. So yeah. The arc. Center part. Start point and the end point. Always ensure that you select the center point so that you can quickly use all the objects that is already available here. You can click on the up arrow to quickly select the latest option that is available and ensure you are selecting the center here. And the first and second point always to be in the anti-clockwise direction. Yeah, so with this we have constructed the center part of your friction plate. So now let us go back and now draw the external component. The next component what we've seen is the slot area where the spring is going to sit in. So towards that you can see that the pitch circle diameter is same as the inner circle diameter, that is the external slotted spring area, that is 122 mm dia, and the external circle is 154 mm in dia. So let us draw two circles for that manner with this same center point, diameter was 122, as well as one more circle with the same center point of diameter 154 mm. So now the slot, as you could see, is from the center point along this axis or this axis, it is 15 degrees towards this and this side. So we can use the same option that we have done earlier, but now let us use the line command to do it. So what we are going to do is, the start point let us specify as here, and then let us give an arbitrary line, that is say as 100 mm, but the next point as an angular approach setting is, it's always measured in 0 from this point. So the line, it should be 15 degree from 90 degrees, so it means that the angle is 75 degrees here. So this has constructed this point here. So likewise, you can, as it is uniform, you can, okay, right now let us trim this out. So instead of using break command, one more thing what we can use is, you can select this object polyline and then click and drag it. So now you can see it is coinciding onto the intersection point. So alternatively, this is internally what's doing is, it's using the stretch or lengthen command that we'll see in the ensuing classes. But right now we can click and drag to reposition it. So now let us use the mirror command to replicate this object, enter, along this vertex. So I am using F8 mode to ensure that we have the orthogonal command. So next, by default it asks whether we have to erase the source object or not, and by default it's no, so we are selecting no. So now you can see this object has been created. So we have to create the other objects also. So let us use the array polar command again to replicate this. So we are going to replicate this two lines with the center here, and the number of instances is going to be 4. So now you can see that the intended shape is coming into fruition. So now we are not required of this inner circle except for these points. So let us again take this off, and also this. So let's see the same way of using the R command for the inner point as well. So center, I'm removing the ortho command F8. So selecting the start point here and the end point here. And similarly, one more R command with the center as here, start point and the end point. Now we can use the array polar again to select these two objects and selecting the center point as here and selecting as 4 again. So now you can see it has beautifully constructed both as the spring area as well as the rivet hole areas also. So this is how we can extensively use just the basic commands of move, offset, command to ensure that we are getting the intended shape quickly and fastly. This array polar is a heavily reliable tool that you have to be very familiar so that you can use it to your benefit. So next, let's draw the reverting holes. So we'll use the circle command. So the center point is located on this PCD. So towards that, right click and go for the snap override and select the from option. So you are offsetting from this point at a distance of 61 mm, that is as the PCD diameter is 122. So the outer radius is going to be 61. And next we are going to enter the angle. As you can see, this hole from the center axis here, it is offsetted by 30 degrees. So again, the angle is going to be measured from this. So it's going to be 60 degrees from this point. So you have got this center point located. Next is the diameter. So the diameter of this hole is 12 mm. So now it's got positioned here. So now let's again mirror this out, or you can offset by 30 degrees here. So let us, you can take in both ways. Let us try the mirror out command first. So this is your object, and your center line has to go through this object. So let us try and see whether we are getting the center line here. Yeah, so this is the midpoint here, so we are not erasing it. So see, using a mirror command, we have mirrored this object to here. So now this hole in this dimension. So let us quickly check whether our intended calculations is correct or not. So you can just measure the angle, this. Okay, so rather you have to use the dimension command to ensure it. Okay, so let us park it a while now, but you can see the dimensions are perfect here. So next we have to use the array polar commands to move these objects across the PCD. Yes, so with this we have constructed the friction plate element. So the dimension part, let us hold it a while now. The quick way of dimension checking is you can use this dimension command to check whether the objects are in the same dimension or not. But here you have construction lines and so. So in the next sessions, what we'll do is we'll look into the different line types and weights. So there you can ensure how the dimensions are located and how to construct a construction line, and from then how to measure the angle. But here in this session what we have seen is we have used the fundamental editing and drafting commands to ensure that we are able to arrive at the final drawing effectively. So with this we'll summarize and close the final week 3 session. So this week what we have seen is different navigation techniques that will help us to go around the object what we are drawing in AutoCAD. So first we started off with zoom command. We looked into the different sub options available in zoom. That is all, or center, or dynamic zoom, or zoom to extents, zoom to the previous version, previous views, then zoom to scale, or zoom to scale of page, or zoom to a specific window, or zoom to object. Next we had looked into the pan command to move the screen with reference to different requirements. Next we had detailedly looked into the functionality of steering wheels. We had looked into 2D wheel, view objects, tour building view, and also the full navigation view. And also we had looked into the different mini wheels that are available for each and every one of the previous application. And next we looked into solid drawing and donut drawing. So those are 2D solid models. So with that we were able to draw solid quadrilaterals, solid triangles, or solid circles. So with that we also seen how we can make use of the regen facility to ensure that the object regenerates for better computing and viewing performance with the current extent or current view space. So next we also looked into how turning on or off the fill command to ensure it is having less impact on the plotting device. So after seeing this drafting techniques, we also looked into selection techniques. So in selection, by default we had the box selection, and in box selection, based on the right or left hand side positioning of the second point, we were able to select either all the objects inside the window or passing through the window as a blue and green icon respectively. So in the same way, we also looked into W polygon and C polygon to have a polygon based selection window. Next, we also looked into fence command, wherein we had the liberty to draw lines through the objects that are interest so that those can be selected, and it was an open-ended selection, whereas all the previous selection options were close-ended. So next, we also looked into individual selection commands using select command and using addition or removal of the selected objects. And also we saw that for certain commands that require selection, we could pre-select the objects and then invoke the respective commands such as move or offset, so that the pre-selection menus are considered for. So finally we looked into a sample drawing of a friction plate, where we had used the basic techniques what we have learned over the weeks, that is circle, arc, rectangle commands for drawing, also with line command. Next, we used editing commands such as move and then break. So with this, then we also looked into array polar options to replicate different views, and also we had used mirror commands to replicate the mirroring of the object. So with this, we conclude the week 3 session of AutoCAD training.